press the bell icon on the YouTube app and never miss another update.
Hello students. So today let us continue with the exercise 15.1. Okay. Now 15th question. Now I am going to read the question for you. 5 cards, the 10, Jack, Queen, King and Ace of diamonds are well shuffled with their face downwards. One card is then picked up at random. First question, what is the probability that card is the Queen? Second one, if the Queen is drawn and put aside, what is the probability that the second card picked up is an Ace, B, a Queen? So you have to understand the question. The previous sum, that is 14th one, I did the card problem. So but in this only 5 cards they have given. One is the 10, Jack, Queen, King and Ace of diamonds. Okay. Now what is the probability the card is the Queen? So when you pick among 5 cards, if you pick Queen, then what is the probability? Of course you all know the answer, that is 1 by 5. Okay, it is easy. But the second one is a little bit tricky there. A Queen is drawn and put aside. A Queen is drawn and put aside. So what is the probability that the second part picked up is an Ace? So out of 5 cards, suppose if you draw Queen is picked up and it is put aside. So only 4 cards are considered. So an Ace is only 1 there. So 1 by 4 is the answer. Then a Queen. See, this it's not possible, impossible event. Why? Because a Queen is drawn and put aside. You see, you have to read the question carefully. A Queen is drawn and put aside. So there is no Queen card there. So what is the probability? Definitely it is 0, 0 by 4. Okay, I hope you understood that. But I told you, writing the answer, yes, of course it is important, but before writing the answer you just see what are the points to be written. Okay. So you can observe the example problems which they have given in your textbooks. So accordingly you have to write the statements. Okay. So the first one, I will write the points there. What is the probability the card is the Queen? So first let us write the number of solution for the 15th question, exercise 15.1. So the number of possible outcome is 5, because 5 cards are there. So the number of possible outcome is 5. Next, the outcome favorable to the event. What is that event? Event is the card is the Queen. Okay. Denoted by, so I told you earlier, you can denote by any alphabet denoted by E. If suppose E, if you take, then it is only 1, because out of 5, 1 card is Queen. Therefore, the number of possible or outcome favorable to the event, that is getting Queen card, is only 1. Hence P of E, that is probability of that event will be 1 by 5. Okay, you have to write all these statements. Then, if the queen is drawn and put aside, what is the probability that second card picked is an ace? So, number of possibilities. Next sub question, this is first one. Next, second one. The number of possible outcomes is 4 now, because you can write in a bracket 5 minus 1, because one queen card is, the queen is drawn and put aside. So, you can show that by writing like this, 5 minus 1. From 5 cards, you have picked one and put it aside. So, how many remaining cards? Remaining cards are 4. So, that you can indicate like this. Okay. Next, getting an ace. So, the outcomes favorable to the event. Card is an ace, denoted by F. How much? Only 1. Hence, P of F is equal to 1 by 4. Same way you can write that, the other one, that is, if the queen is drawn and put aside, then what is the probability of getting queen? So, in that second one, they have given the sub question, this is A, in second one this is A and second B. So, same way you have to write the number of possible outcome is 4, because the queen is put aside. So, it is 4 only, no change. The outcome favorable to the event card is the queen. So, when the queen card is put aside, again there is no possibility of getting queen. Therefore, denoted by G, you can put, that is 0. Therefore, so you can't see here, so I will write here. Therefore, probability for this is 0 by 4. Okay, I hope you understood this. See, the answer is simple, but the procedure, the steps you have to write. Okay. Okay. Let us move on to the next one, 16th one. See here, 16th one, I will read out the question for you. 16th one. 12 defective pens are accidentally mixed with 132 good ones. Read the question carefully. It is not possible to just look at the pen and tell whether or not it is defective. One pen is taken out at random from this lot. Determine the probability that pen taken out is a good one. The pen taken out is a good one. So, see, I hope you understood the question. 12 defective pens are there. It is accidentally mixed with 132 good pens. So, just read the question and you can write the procedure now. See. See, first let us write 16th one. Number of defective pens. How many? 12. Then number of good pens. How many? 132. Correct? See, just 12 defective pens are accidentally mixed with 132 good pens. So, probability you have to find out the pen taken out is a good one. Okay. So, see here, defective pens are 12, good ones are 132. Therefore, total number of pens, how many? So, you have to add these two. Okay. So, when you add this, it will become 144. Okay. Now, what is the next step? Now, you have to write the probability. So, before writing, you will write the possible outcome. So, number of possible outcomes. How many possible outcomes? 144. Okay. Next, the outcomes favorable to the event. The outcome favorable to the event getting a good pen. Is getting good pen, how much? See, how many good pens are there? 132. 12 are defective, but total pens are 144. So, favorable, outcome favorable to the event getting a good pen is denoted, okay, is denoted by E or how much? 132. Hence, probability P of E, probability how much? Getting an good pen is 132 divided by 144. So, you know the formula, 132 is the favorable outcome divided by total number of outcome. So, it is 132 divided by 144. You can simplify this. 2 6 are 12, 2 6 are 12, 2 7s are 14, 2 2s are 4, again 2 3s are 6, 2 3s are 6, 2 3s are 6, 2 6s are 12, 3 1s are, okay. Now 11 by 12, or you can directly do 11 by 12 is the answer. Okay. Now, so I hope you understood. If suppose if they have given like this, you should, but you should read the questions carefully, because when you see the next one, you will come to know the difference between these two. Number of defective pens is 12, good pens 132, total pens is 144. Okay. Now, I am going to read the next question for you. 17th one. A lot of 20 bulbs contain 4 defective ones. One bulb is drawn at random from the lot. What is the probability that this bulb is defective? Suppose the bulb drawn in first one is not defective and it is not replaced. Now, one bulb is drawn at random from the rest. What is the probability that this bulb is not defective? Okay. You just see the difference between this sum and the 17th sum. Okay. 20 bulbs contain 4 defective ones. See the difference between the question. See first one, 16th one, 12 defective pens are accidentally mixed with 132 good pens. So, there 12 pans plus 132. But in this case, lot of 20 bulbs, in that only 4 defective. Then how many good bulbs are there then? See, out of 20, 4 are defective. So, 16 bulbs are good ones. I hope it is clear. See the difference between the 16th question and 17th question. Okay, out of 20, 4 are defective. Out of 20 bulbs, 4 bulbs are defective. Then how many are good ones? Good ones are 16. So, we should be careful and read the question carefully. Okay, let us write the out of 20, okay, number of bulbs, how many? 20. Number of defective bulbs, how many? Defective bulbs are 4. Therefore, number of good bulbs, this should be very clear. 20 minus 4, that is equal to 16. Now, what is the probability that the bulb is defective? If you just pick up one randomly, that is defective. So, out of 20, 1 means here 4, there is a possibility of getting 4 defective bulbs. So, 4 by 20, okay, that is the answer. So, let us write total number of bulbs I wrote 20, number of defective bulbs 4. So, number of good ones will be how much? Okay, next. Number of possible outcomes. See how many in a bundle, in a lot, how many the bulbs are there. So, number of possible outcomes will be 20. Okay. Next the outcomes. Outcome favorable to the event. Okay, we will write that event name. What is that event? Event is that bulb is defective. Bulb is defective is denoted by F or 4. Okay. Now, therefore, hence or therefore, probability of getting a bulb defective is 4 by 20, 1 by 5. You can put it in a simple form. Next. So, see the next question, suppose the bulb is drawn and it is not defective and it is not replaced. So, it is not defective and it is also not replaced, means it is kept aside. See, as we did one the previous sum, that is card problem, the same way. It is not defective and also it is kept at the side, and it is not replaced means it is kept at side. Okay. Now one bulb is drawn at random from the rest. What is the probability that the bulb is not defective? See, bulb is not defective means it should be good one. So, how will you write? So, therefore, not defective means now out of 20, one bulb we will keep it aside. Therefore, number of, so for the second one, so I will start right here. So, this will be the first one. For the second one, I will write this is second one now. Okay, for second one, possible number of possible outcomes. See, out of 20, 1 is removed. So, therefore, it is 19. Okay. Next. Favorable outcomes of the event. What is that event? Event is bulb is not defective, means it is good one. See, out of now out of 19 minus 4, how much? 15, because see now when you remove that bulb and you will keep it aside, so there will be number of possible outcome is 19. In that 4 are defective. So, how many good ones will be there in this lot? See, out of 20, we will remove 1, So, when you remove 1, only 19 are there. So, this removed one is a not defective means it is good one. So, 19 are remaining, in that 4 are defective. So, 15 are the good ones. I hope you understood this. Therefore, possible F1 will be equal to 15 by 19. So, this is the answer. 15 by 19 is the answer. Okay, probability of getting good one. Probability of bulb is not defective, means it is nothing but it is a good one. Okay, I hope you understood this. So, let us move on to the next one. Next question, 18th one. A box contains 90 discs which are numbered from 1 to 90. If one disc is drawn at random from the box, find the probability that it bears a 2-digit number. Second one, a perfect square. Third one, a number divisible by 5. Okay. Now, just will write. Eighteenth one. A box contains 90 discs which is numbered from 1 to 90. So, 2-digit numbers, you all know how many 2-digit numbers are there, you have to find out between 1 to 90. So, between 1 to 90. So, how many numbers are there? First you have to find out that. So, 1 to 90, how many numbers are there? So, first total number of discs, how many number of discs are there? So, total number of discs. So it is from 1 to 90, means how many are there? 90. Okay. Then 2-digit number, total number of discs having 2-digit numbers. I hope you understood this. 2-digit number means it will start from 10 up to 90. I hope you understood this. 2-digit number. So 1 to 9 you have to leave it off. Then 10 to 90. So how will you find out how many digits? So 90 minus 10 is 80 and including this, so 1. So 81. 90 minus 10 is 80 and you have to include 1 because you have to include 10 and also 90 there. So 90 minus 10 plus 1. So that is 81. Okay. Now what is the probability of, so total number of outcomes, so or number of possible outcome. Number of possible outcomes. How many? 81. Sorry, 90. Number of possible outcome, total number 90. The favorable the outcomes of getting 2-digit numbers. The outcomes favorable to the event of getting 2-digit number is denoted by A R, how many? 81. Okay, getting 2-digit number is 81. There ends P of A. Probability of getting 2-digit number is how much? 81 by 90. Okay, 9 9s are 81, 9 10s are 90. 9 by 10 is the answer. Okay. So let us see the next one. That is a perfect square. So I hope you all know the meaning of perfect square. What a perfect square? 1 into 1, 1 square, 2 square, that is 4. Perfect square, these are the perfect square. 3 squares, that is 9, 4 square, 16, 5 square, 25, like that. So the number of perfect squares, see, 1 square, 2 squares, 3 squares, 4 square, 5 square, 6 square, 7 square, 8 square, 9 square, 10 square, 10 square is 100, which is not there here, between 91 to 90. See, 1 square is there, 1 is from 1 to 90 means 1 is also present. Then 2 square means 4, yes, in between this. 3 square 9, 4 square 16, 5 square 25, 6 square 36, 7 square is 49, 8 square is 64, 9 square is 81. Suppose if you take 10 square it will be 100. So 100 is not present in this number, in this disk. So we cannot take that. Then how many possible outcomes here? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. Possible outcomes are 9 numbers. I hope you understood that. Okay. Now I will write that. So total number of discs is same, and here I will rub from here. So, number of possible outcomes is 90 only. Number of possible outcomes, there is no change. Therefore, the outcomes favorable to the event getting perfect square. Denoted by B are how many? So, you can write possible 1 square, 2 square, also you can write, or you can write 1, 4, 9, 1 square, 2 square, 3 square, 4 square, 5 square, 6 square, 7 square, 8 square, 9 square. Okay. So, 1, 2, 3, 4, 5, 6, 7, 8, 9. Therefore, how many? 9 are there. Hence, probability of getting this a perfect square is how many? 9 by 90, that is 1 by 10. Okay. 9 by next. Now multiple of 5. So the same way you have to see the number of numbers which are divisible by 5. Sorry, not multiple, divisible by 5. Okay. Now a number which is divisible by 5. Okay. Now these 3 steps are same. So the outcome favorable to the event, I hope you understood this, perfect square. Now we shall see divisible by 5. Event divisible by 5. Okay, the number getting divisible by 5 is denoted by C R. Now just see from between 1 to 90, divisible by 5 means you all know. So 5, 10, 15, 20, 25, like this, so on. So that I am going to write here 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, and 90 also. You should include 90 also, okay, because the cards are there 90. So 5, 10, 15 like that. So how many will be there? You have to check 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So 18 possible favorable outcomes are 18. How many? 18. Hence probability 18 by 90. So 9 2s are 18, 10s are means 1 by 5. Again 18 by 12, that is 1 by 5. I hope you understood this. So there are 18 possibilities. 18 favorable outcome. So the probability will be 18 by 90. Okay, now I hope you understood this type. So one more sum I will do, 19th one, then we shall continue in the next class. 19th one, it is a very easy problem. A child has a die whose 6 faces shows the letter as given below. So, a child is having a dice. Usually we will say, it will be 1, 2, 3, 4, 5, 6, but in this case they have A, B, C, D, E and A. So, the die is thrown once, what is the probability of getting A and what is the probability of getting D? Okay. Now, a child has a die whose 6. So, number of possible outcomes. How many? 1, 2, 3, 4, 5, 6. 6 are there. Then the outcome favorable to the event E, that is getting A, possibility of getting A. So, how many are there? Is denoted by E1. How many possibilities are there getting A? You have seen there are 2 cards having A alphabet, correct? Therefore, possible is 2, getting 2. Next, hence P of E1 is equal to 2 by 6, 1 by 3. Okay, it's very easy one. And possibility of getting D. Okay, I will complete here only. The outcome, I will start from here. This is second one and this is first one. The outcomes favorable to the event. Here I have taken to the event E dot to the event that is getting D. Okay, hence is denoted. I will take E2. Getting D, only one card we have, one alphabet, that is only D is only once. So, 1. Hence, P of E2 will be 1 by, so how many total outcome? 6, 1 by 6. So, this is answer 1 by 3 and 1 by 6. I hope this is a very easy problem. Okay. So, the last part I am going to continue in the next class. Thank you.